Welcome to this math channel. Today, let us discuss arithmetic series and summation notation. Let us start with some definitions. A series is the indicated sum of the terms of a sequence. For example, in a finite sequence, 2, 7, 12, 17, 22. The indicated sum is given by 2 plus 7 plus 12 plus 17 plus 22. And for the infinite sequence, that is the sequence of positive odd integers, we have 1, 3, 5, 7, and so on. The indicated sum is given by 1 plus 3 plus 5 plus 7 plus and so on. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. For example, the indicated sum of positive odd integers 1 plus 3 plus 5 plus 7 plus and so on is an example of an infinite arithmetic series. The sum of the first n terms of an arithmetic series is denoted by S sub n. This is also called the nth partial sum of an arithmetic series. Hence, the partial sum of the first four terms in the series of positive odd integers is given by S sub 4 equals 1 plus 3 plus 5 plus 7. And since 1 plus 3 plus 5 plus 7 is 16, the partial sum S sub 4 of the series is equal to 16. To derive the formula for the partial sum S sub n of an arithmetic series, we write S sub n in two ways and add the two equations term-wise. One is S sub n is equal to A sub 1 plus A sub 2, that is written as A sub 1 plus the common difference, plus A sub 3, that is A sub 1 plus 2 times D, that is A sub 3, plus A sub 4, that may be written as A sub 1 plus 3 times D, and the pattern continues until A sub n. The other way is to write S sub n with addends written in reverse order, beginning with A sub n, and to write the next term to that, subtract the common difference. Then the next term will be A sub n minus 2d, then plus A sub n minus 3d, and the pattern continues down to A sub 1. Adding the two equations term-wise, we will have 2 S sub n on the left-hand side and A sub 1 plus A sub n plus D plus negative D is 0, so we have another A sub 1 plus A sub n. Also 2D plus negative 2D 0, so we have another A sub 1 plus A sub n. 3D plus negative 3D 0, so we have another A sub 1 plus A sub n, and the pattern continues until the last pair of addends, we have A sub 1 plus A sub n. Since the series have n number of terms, the right-hand side may be written as n times the quantity A sub 1 plus a sub n. Dividing both sides of this resulting equation by 2, we'll have s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. And this is the formula for the partial sum s sub n of an arithmetic series given n, the number of terms, a sub 1, the first term, and a sub n, the nth term of the series. Now, since a sub n is equal to a sub 1 plus n minus 1 times d, we can have another formula for partial sum s sub n of an arithmetic series. Let us do that. So we have s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n, that may be written as a sub 1 plus n minus 1 times d. Simplifying the equation, we have s sub n is equal to n over 2 times the quantity 2a sub 1 plus n minus 1 times d. So this will be the formula for the partial sum s sub n of an arithmetic series given n number of terms, a sub 1 the first term, and d as the common difference. Let us have some examples. Find the sum of the first 15 terms, s sub 15, of an arithmetic series if a sub 1 equals negative 5 and a sub 15 equals 23. In here, we are given a sub 1 and a sub 15, that is a sub n. So we can use the first formula, and let us recall that is s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Substituting the values for a sub 1 and a sub 15, where n is equal to 15, we have s sub 15 is equal to 15 over 2 times the quantity negative 5 plus a sub 15 is 23. Negative 5 plus 23 is 18. So we have 15 over 2 times 18. 18 divided by 2 is 9. Therefore, s sub 15 is equal to 15 times 9, that is 135. Example number 2. Find the sum of the first 10 terms in the series 4 plus 7 plus 10 plus 13 plus ... In here, we are given the first term, a sub 1, that is equal to 4. Also, we can get the value of d, that is the common difference, by subtracting 7 minus 4, 10 minus 7, 13 minus 10. These are all equal to 3. So we're given the first term and the common difference. We can use the second formula, and let us recall. S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. N is equal to 10 since we're looking for the sum of the first 10 terms. So we have s sub 10 equal to 10 over 2 times the quantity 2 times a sub 1, that is 4, plus n minus 1, n is 10, so we have 9 times d, which is 3, 9 times 3. 10 over 2 is 5, 2 times 4 is 8. And 9 times 3 is 27. 8 plus 27 is 35. So we have 5 times 35. Therefore, S sub 10, or the sum of the first 10 terms of this series, is equal to 175. The sum of a series may be written using a shorthand method called the sigma notation or summation notation. This is read as the sum of a sub n from n equals I to k, where a sub n is the nth term or the general term of the series, n is the index of the summation, I is the lower bound or the lower limit, and k is the upper bound or the upper limit. For example, write S sub 10 in example number 2 using summation notation. Let us recall the series in example number 2, that is 4 plus 7 plus 10 plus 30 plus ... We know that A sub n is equal to A sub 1 plus n minus 1 times d. And A sub 1 is equal to 4, so we have 4 plus n minus 1. The common difference is 3. So we have A sub n, simplifying the equation, equals 4 plus 3n minus 3. Then the general term or the nth term of the arithmetic series is equal to 3n plus 1. So to write the series in summation notation indicating S sub 10, we have the summation of 3n plus 1 from n equals 1 until 10. Let us have another example. Write the summation of 3k plus 1 from k is equal to 1 until 5 in expanded form and find S sub 5. To write the summation notation in expanded form, we need to find the first, second, until the fifth term of the series. So to find A sub 1, we substitute k is equal to 1 to the nth term of the series. So that is 3 times 1 plus 1. So the first term is equal to 4. For the second term, we have 3 times 2 plus 1, that is equal to 7. And the third term will be 3 times 3 plus 1, that is equal to 10. And A sub 4 will be 3 times 4 plus 1, that is equal to 13. And A sub 5 is equal to 3 times 5 plus 1 equal to 16. Hence, the indicated sum for S sub 5 is equal to 4 plus 7 plus 10 plus 13 plus 16. S sub 5 is equal to, we have 4 plus 7, 11, plus 10, 21, plus 13, 34, plus 16, that is equal to 50. This time, let us have some practice exercises. In the practice exercises, you will be given 15 seconds to answer each item. You may pause the video if you need more time to answer, and play it again to check whether your answer is correct. Let us begin. Find the sum of the first 19 terms of the series 2 plus 9 plus 16 plus 23 plus ... Go. Time is up. Let us check the answer. In here, a sub 1 is equal to 2. D is equal to 7. That is obtained from subtracting 9 minus 2, 7. 16 minus 9, 7. 23 minus 16, 7. So we have a common difference of 7. N is equal to 19, since we're looking for the sum of the first 19 terms. Using the formula, S sub n is equal to n over 2 times the quantity 2a sub 1 plus n minus 1 times d. And substituting the values, we'll get S sub 19 is equal to 19 over 2 times the quantity 2 times 2 plus 19 minus 1 times d, which is 7. So we have 19 over 2 times 4. 19 minus 1 is 18 times 7. That is 126. So we have 19 over 2 times 130. And 130 divided by 2 is 65. Then multiply 19 times 65. That is 1,235. Next, find the sum of the first 20 terms in an arithmetic series if a sub 1 equals 5 and a sub 20 equals 62. Go. Time is up. Let us check the answer. In here, a sub 1 is equal to 5. A sub 20 is equal to 62. And n is equal to 20. We will use S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Substituting the values, we have sum of the first 20 terms, that is S sub 20 equal to 20 over 2 times 5 plus 62. 20 over 2 is 10. 5 plus 62 is 67. So the sum of the first 20 terms is 670. Next number. Write the series -1, -3, -5, -7, minus ... in sigma notation and find the sum of the first 30 terms of the series. Go. Time is up. Let us check the answer. From the formula, a sub n is equal to a sub 1 plus n minus 1 times d, we'll get the general term of the series. So we have a sub n is equal to a sub 1 is -1 plus n minus 1 times d. To get d, we have -3 minus -1, that's -2. -5 minus -3, that's -2. So we have -2 as the common difference. So we have a sub n is equal to -1 minus 2n plus 2. Hence, the general term of the series is -2n plus 1. In sigma notation, this is the summation of -2n plus 1 from n equals 1 until 30. To get the sum of the first 30 terms of the series, let us find a sub 1. That is when n is equal to 1. So we have negative 2 times 1 plus 1, that is negative 1. And a sub 30, that is when n is equal to 30. So we have negative 2 times 30 plus 1, that is negative 59. So to find the sum of the first 30 terms, we have s sub 30 is equal to 30 over 2 times a sub 1 plus a sub n. So we have 15 times negative 1 plus negative 59 is negative 60. Therefore, s sub 30, or the sum of the first 30 terms, is equal to negative 60 times 15, and that is equal to negative 900. That will be all. Thank you for watching. Please subscribe for more math lessons.